Namaste everyone. This is Disha, an electronics and communication student at Sri Venkateshwara College of Engineering. I'm here to give a presentation on working of solar cell. What is solar cell? A device converting solar radiation into electricity. Solar cell is also called as photovoltaic cell. It is a device that converts energy of light into electric energy through the photovoltaic effect. And there is another device that directly converts the energy of heat into electric energy. Working principle of solar cell. A solar cell is a PN junction device that converts energy of light directly into electricity by using photovoltaic effect. The principle of solar cell is generation, separation and collection of the free charge carriers. The below diagram shown is solar cell diagram. When sunlight directly strikes the solar cell, energy from the light is absorbed by the semiconductor material, that is PN junction, and causes electrons in the material to become energized, which creates a flow of electricity. This electricity can be used to power anything from a calculator to an entire home. What is photovoltaic cell? A solar cell is also known as photovoltaic cell. It is a device made of special materials that convert solar energy directly into electricity. Solar cells come in all shapes and sizes, but the most efficient ones are those made from a single crystal of highly purified semiconductor material such as crystalline silicon. Solar cells are electrochemical cells that converts the energy from sunlight into direct current. Solar cells have numerous small electrical parts that work together to create an effect known as photoelectric or photovoltaic cell or effect. Solar cells can be connected together to form large photovoltaic arrays which are used to generate power for an entire building or community. Some solar cells are even powerful enough to generate hundreds of kilowatts of electricity. Working of photovoltaic cell. The first step in understanding how solar cells work is to know that sunlight consists of photons. These photons have different levels of energy, and when they land on the solar cell, the cell is designed to absorb some of the energy from the photons and convert it into electricity. And this step can be defined as the capture effect also, which the solar cell has to capture the photons from the sun and convert these photons into the some electricity energy. As we studied in the previous slide, solar cells are made up of layers of semiconductor materials, usually silicon. The atoms of these materials are altered through a process known as doping. This process adds other elements like boron and phosphorus, which changes the electrical properties of the material. If doping is done correctly, the upper layer or the top layer of the material will be negatively charged with an excess of electrons, and the bottom layer will be positively charged with an excess of holes or in the absence of electrons. This allows the solar cell to conduct electricity. Inside the cell, there is an electric field created by the different charges of the doped silicon and the metal contacts. When sunlight strikes the cell, The light particles or photons transfer their energy into the electrons in the material. This loosens the bond within the material, freeing the electrons and creating an electric current. This electric current then runs along the circuit connected to the solar cell, exposing the current to external devices such as photovoltaic panel or a battery, which can be used for the further purposes. The number of photons absorbed by the solar cell and the material it is made from determines the amount of electricity created by the cell. Finally, regular maintenance and cleaning of the solar panels is required to ensure optimal performance. This includes checking the panels for dirt and debris to ensure it can capture the most sunlight and providing shade or covering the solar panel when needed, as exclusively sunny weather can be damaging. Conclusion: therefore, solar cells are able to convert energy from sunlight into usable electricity. Solar cells are becoming increasingly more efficient due to newer technologies and materials. Currently, they are most commonly used to power homes and businesses as well as to provide electricity in remote or low income areas. In 2022, we had a report that India uses 63% of renewable energy is of solar energy. Where solar cells are used. Solar cells are most commonly used in residential and commercial applications to generate electricity and power. Solar cells are also used to power many small devices and are found in a variety of small gadgets such as calculators and timepieces. Solar cells have the potential to be used for large scale applications as well. They are used to power satellites and spacecraft and are also used in large solar thermal energy projects. Solar cells also have the potential to be used for large scale energy storage, allowing for the capture and storage of energy from the sun for use during times when the sun isn't available. In addition to these applications, solar cells are also increasingly being used to power transportation, such as in the form of solar powered vehicles, and some countries are beginning to use solar cells in the form of solar roadways to provide electric power. Here is the small diagram of the photovoltaic cell. These are the sun rays falling on this solar panel where the semiconductor material capture the sunlight and the electrons energize the photons, and this semiconductor material converts the energy of photons into the electric energy. Thank you for watching the video, guys. Please like, share and subscribe.